We use water out of our fridge and sink every day, from drinking it to using it to make pasta. But where does this water come from, and how does it get to our home? We get water from lakes, rivers, and groundwater, but you can't just go out to a lake and drink the water. The water has to be treated for it to be drinkable. Water goes through many stages to get clean. Step 1. Coagulation and flocculation. Coagulation and flocculation are often the first steps in water treatment. Chemicals with a positive charge are added to the water. The positive charge of these chemicals neutralizes the negative charge of dirt and other dissolved particles in the water. When this occurs, the particles bind with the chemicals and form larger particles called floc. Step 2. Sedimentation. During sedimentation, floc settles to the bottom of the water supply due to its weight. This settling process is called sedimentation. Step 3. Filtration. Once the floc is settled to the bottom of the water filter, the clear water on top will pass through filters of varying compositions: sand, gravel, and charcoal, and pore sizes, in order to remove dissolved particles such as dust, parasites, bacteria, viruses, and chemicals. Step 4. Disinfection. After the water has been filtered, a disinfectant, for example, chlorine, chloramine, may be added in order to kill any remaining parasites, bacteria, and viruses, and to protect the water from germs when it is piped to homes and businesses. Step 5. The clean, filtered, drinkable water is then sent through an underground pipe to your local water towers that send water straight to your sink for you to drink.
We wanted to try building our own water filter to mock how water is cleaned in the water treatment plants, and to clean and lower the turbidity of the water we collected. We made our own filter from a 2-liter soda bottle, coffee filters, sand, gravel, and activated carbon. First, gather your materials and prepare them properly. Rinse the gravel and sand in the water to make sure they do not contain any dirt or dust. Next, prepare the activated carbon. The finer the particles, the more surface area, and therefore the more effective it becomes at absorbing pollutants. Grind up the activated carbon into a powder-like substance. Cut the bottom of the 2-liter bottle off using an X-Acto knife so the bottle measures 10 inches from the cap to the opening.
Now it is time to start filling the bottle with the carbon, sand, and gravel. The order in which the substances are put into the bottle is important. The biggest options at the top and the smallest at the bottom. Start by placing the coffee filter in the bottom, and then gradually fill the activated carbon until it is 2 inches high, then sand 2 inches high, and then gravel 3 inches high. Remember to leave a gap of at least a few inches at the top. This allows the water filter to fill up with a decent amount of water each time it is used. Once everything is inside of the filter, put the filter into something that will catch the filtered water, such as a pitcher or a cup. Pour the water sample in one at a time and wait for it to come out at the bottom into the pitcher. Next, we had to get some water samples. We got lake water from Lake Lavon, Water Creek in our neighborhood, and water from our faucet at home. We want to test and compare the nitrates, chlorine, and alkaline levels in all of the water samples before and after filtering it. We tested the chlorine by using AquaCheck, which are strips to test chlorine and alkaline levels. To test the nitrates, we used a nitrogen kit that Ms. Carrico provides us. To find the number of organisms in the water, we looked through the microscope and counted as many as we could see. To find their turbidity, we used a scale to determine the NTU.
Jungle. Audio Jungle. Audio Jungle. Audio Jungle. Audio Jungle.
Analyzing the data. As you can see in the data, the tap water has 0.4 milligrams per liter of chlorine in it. This is because chlorine is a big part of water treatment. Small amounts of chlorine are added to public water sources and treatment plants to eliminate traces of bacteria, viruses, and parasites as the water travels to its point of use. Even treatment plants that use non-chlorine disinfection agents are required by law to add small traces of chlorine before distribution. This is why the water that comes out of your faucet sometimes smells like chlorine. However, over the years, researchers have found that the people who are exposed to chlorinated waters over long periods of time have a greater risk of getting bladder cancer, cell damage, and increase the risk of asthma attacks. On the other hand, the lake water started off with 1.5 milligrams per liters of chlorine because there was a sewage spill not too long ago that contaminated the lake with many things, including chlorine. But once we filtered it, it had none. Traces of nitrates were found in the lake and creek water. But why? Well, nitrogen fertilizers are applied to yards, fields, golf courses to promote the growth of plants. Rainwater can wash nitrates into the fertilizers into lakes. City sewage treatment plants treat sewage to make it non-hazardous, but treatment plants still release nitrates into waterways. If you drink water that is high in nitrates, it can interfere with the ability of your red blood cells to transport oxygen. However, when the water samples went through our homemade water filter, the nitrates decreased, but there was still a very little amount of nitrates because the water has to be boiled for it to be completely removed. The amount of organisms decreased in both samples by a lot. When the water is poured through the filter, and gravel and sand catch and trap all the tiny organisms. The alkaline levels of the filtered water samples are similar to the non-filtered water. This is because the filter does not trap the alkaline. However, this is a good thing because water with higher alkaline levels have a higher pH level than plain tap water, and it can neutralize acid in your bloodstream. Some say that alkaline water can help prevent disease, such as cancer and heart disease. Similar to water treatment plants, each layer of the homemade water filter has a purpose. Gravel or small stones are used to filter out large sediments like leaves or insects, whereas sand is used to remove fine impurities. Finally, the activated charcoal removes contaminants and impurities through chemical absorption. The filter lowers the turbidity of the water. All of these parts of the filter can make natural water drinkable.
Audio Jungle.